Well, Bill, today we conclude our series of podcasts responding to a YouTube video which features an impressive array of philosophers and physicists critiquing the Kalam Cosmological Argument and specifically targeting you. It's called Physicists and Philosophers Reply to the Kalam Cosmological Argument, featuring Penrose, Hawking, and Guth. It fits neatly into 4 segments, so we're concluding with our 4th podcast today. We've looked at the first philosophical argument for the beginning of the universe in the first podcast, the second philosophical argument for the beginning of the universe in the second one. Last time we looked at the scientific evidence for the beginning of the universe, and today, the need for a cause of the universe's beginning. And we'll just offer this disclaimer again that there's no way we can possibly respond to everything in the video in these short podcasts. But Bill, you've also included some more material in the Question of the Week feature at reasonablefaith.org. So I want to invite everyone to go there.
Question of the Week 770 to 773 will cover all 4 sections of the video.
Let's go then to the first excerpt from the video today.
The Big Bang doesn't prove the universe had a beginning, only that it evolved from a very hot, dense state. But when it comes to physics, the Kalam advocate has another card to play: the second law of thermodynamics. The second law states that entropy, which is roughly a measure of disorder, increases with time. And so the argument goes, if the universe were eternal into the past, we would already be in a maximal entropy state. Since we aren't, the universe can't be past eternal. This also related to the mystery of why the Big Bang was in a surprisingly low entropy state. But what if the universe were infinite?
Perhaps we're living in a physical system where there's no maximum possible entropy. Suppose the entropy can just grow forever. And an eternally inflating universe looks like such a system, although nobody really knows for sure how to define the entropy of an eternally inflating universe. But if it's the case that entropy can grow forever, then any state is a state of low entropy because it's low compared to the maximum, which is infinite.
The puzzle of our universe's initial low entropy condition, which is universally recognized, cannot be so easily dismissed. The problem doesn't presuppose that there is a maximum entropy for the universe. It's enough that compared to today, the initial entropy was astonishingly low.
This next clip.
What we need to consider is not just the entropy of matter, but also entropy associated with horizons, so to say, the gravitational entropy. In the contracting branch, because the dynamics is different from Einstein's theory, a horizon develops, but it grows extremely rapidly. This entropy dominates completely the entropy of matter. Therefore, the entropy is really growing very rapidly, but then at the bounds, the geometry is such, which is non-trivial statement, is such that, in fact, the area of this horizon becomes infinite. And then after that, the horizon simply disappears. So if you like, what one has to do is to reset the entropy clock, in a certain sense, at the bounds.
This amounts to nothing more than a description of what happens in his model. It goes no distance toward showing that the model is plausibly the true description of the universe. The producers of this video don't seem to understand that it's not enough simply to float theoretical models. One has to provide some sort of evidence on their behalf.
They play an excerpt from one of your videos in this next clip. Bill?
What if the universe did have a beginning? In the 1970s, Edward Tryon claimed the universe might arise as a quantum fluctuation of the vacuum. But this still raises the question, where did the vacuum come from? In 1982, Alex Vilenkin suggested that if space itself was treated quantum mechanically, it could quantum tunnel into existence. He titled his proposal, Creation of Universes from Nothing.
Now, sometimes skeptics will respond to this point
by saying that in physics, subatomic particles, so-called virtual particles, come into being from nothing. This skeptical response represents, I believe, a deliberate abuse of science. The theories in question have to do with particles or the universes originating as a fluctuation of the energy contained in the vacuum. The vacuum in modern physics is not what laymen understand by vacuum, namely nothing. Rather, in physics, the vacuum is a sea of fluctuating energy governed by physical laws and having a physical structure. To tell laymen that on such theories something comes from nothing is a distortion of those theories. Properly understood, nothing does not mean just empty space. Nothing is the absence of anything whatsoever, even space itself. How silly then when popularizers say things like nothingness is unstable to quantum fluctuations, or the universe tunneled into being out of nothing. Right, I'm speaking here of vacuum fluctuation models like tryons.
Here's Alexander Vilenkin.
When we say nothing in this context, tunneling from nothing, we don't mean quantum vacuum. It's actually what a tryon meant. Here we have a state without space completely. So there is no vacuum.
Vilenkin's quantum cosmological model is different than tryon's, whatever tryon may have meant. The old vacuum fluctuation models are now obsolete, having been refuted, but Vilenkin's model still remains on the table.
Here's more from Vilenkin.
But if the universe did quantum tunnel into existence, what caused it?
Many quantum mechanical processes do not require a cause. So, for example, if you have a radioactive atom, you know that it will decay, but you cannot tell when. There is a half-lifetime. For example, you can tell that in a year, the probability for this atom to decay is 50%. Then the year has passed, it didn't decay. The probability for it to decay the next year is still 50%. Eventually, it will decay. But if you ask why did it decay at that particular moment, there is no reason. There is no cause. So quantum mechanical processes like this are uncaused. The spontaneous creation of the universe is of the same nature.
Notice that Vilenkin just assumes here the Copenhagen interpretation of quantum mechanics, according to which quantum indeterminacy is ontic rather than merely epistemic. There's no justification for this. There are, moreover, at least 10 different physical interpretations of quantum mechanics, which are empirically equivalent and some of which are fully deterministic. So this is not a proven counterexample to the metaphysical principle that whatever begins to exist has a cause. I've responded to Vilenkin's claims about physics being able to explain how something can come into nothing on our website under Popular Writings, The Existence and Nature of God, the section on Creatio ex Nihilo, Theology and Science. And so I would refer our listeners to that article.
And Bill, someone you've debated a couple of times, here's Arif Ahmed.
The notions of quantum mechanics place severe pressure on our everyday ideas of causality. You might say, well, there are some interpretations of quantum mechanics that allow for causality and determinism, and it's true there are, but then there are other interpretations that don't.
Right, so quantum mechanics is not a proven counterexample.
Here's the next clip.
Since the Kalam asserts that everything that begins to exist has a cause, its defenders carry the burden of proof to show causality is maintained in quantum mechanics.
No, I provide 3 arguments in support of the causal principle. To defeat it, the objector has the burden of proof of showing that there is a proven counterexample to the principle.
Alastair Wilson in this next clip.
So the different interpretations of quantum mechanics do differ a lot in terms of the role of causality. Start with the Bohm interpretation, or Bohmian mechanics, or the pilot wave theory. That is the most like classical mechanics when it comes to causality. Causality is deterministic, and cause necessarily follows effect according to the law. A bit of more of a deviation from the classical approach to causality comes in collapse theories, dynamical collapse theories, or the GRW approach. And these theories have irreducible randomness in the way the world turns out. So, an effect need not necessarily follow a cause. A given cause could lead to many effects with different probabilities of each one. And there would be nothing in the world that explains why one effect happens rather than another. Any of them could have done. It was just random. And so that weakens the link between cause and effect. Instead of being ironclad necessity, it's probability. The cause makes the effect more probable. And I think that's a big change to the role of causality. But there's a bigger change still, potentially, to the role of causality in the many worlds interpretation, or the Everett interpretation. People often call that a deterministic interpretation, in that they say we have the quantum state of the universe, and deterministically there evolves a multiverse, a system of many parallel worlds. But there's an open question as to whether we should call that process causation, and we should call that causality. My own preferred approach to understanding many worlds has it that causality is a process that goes on within each individual world, but not outside or between them. So causation is an emergent process that emerges along with the individual worlds, but is entirely contained within them. And that is perhaps an even bigger change to the concept of causation, because it means it's non-fundamental. It's not part of kind of the deep structure of reality. It's not a concept that's even really properly applicable at the level of the whole universe.
This account nicely illustrates how uncertain the correct physical interpretation of the mathematical equations of quantum mechanics is. And notice, too, that the causal principle of the Kalam Cosmological Argument is deliberately formulated so as to allow for the possibility of uncaused events. What it precludes is things, substances, coming into being without a cause.
More from Alexander Vilenkin.
In the Copenhagen interpretation, things are acausal simply because it's kind of built in the nature of interpretation. You have a wave function describing your atom, and then the wave function collapses in the course of measurement, resulting in some of the outcome probabilistically. And there is no cause how you choose these things. In the case of many worlds, this wave function describes an ensemble of universes. And in different members of the ensemble in different universes, you get all possible outcomes of your measurement. Simply, you don't know which universe you are in. And which universe you end up in is also an acausal kind of process.
Aha! Here he explicitly acknowledges his assumption of the Copenhagen interpretation. But notice that he doesn't provide any justification for thinking that indeterminacy is ontic rather than merely epistemic.
And Daniel J. Linford makes an appearance in this next clip.
In defense of the argument's first premise, Craig makes use of de Broglie-Bohm theory, also known as pilot wave theory. And in defense of the argument's second premise, Craig makes use of neo-Lorentzianism. Now, at least amongst physicists, both de Broglie-Bohm theory and neo-Lorentzianism are considered to be fringe and disreputable. Therefore, although Craig might seem to be simply appealing to common sense or to mainstream science, Craig is actually appealing to theories that do not enjoy wide philosophical or scientific support.
Well, this isn't quite right. The de Broglie-Bohm pilot wave interpretation of quantum physics is simply an illustration of the fact that a mathematically consistent and empirically adequate deterministic interpretation of quantum mechanics is available. It doesn't need to be the correct interpretation to serve that purpose. Although it must be said that this interpretation seems much more plausible than the Copenhagen interpretation, especially when it comes to cosmology, in light of the so-called measurement problem. As for a neo-Lorentzian interpretation of relativity theory, which enjoys the support of some very prominent physicists, I've already explained that the Kalam cosmological argument doesn't depend upon it. Rather, it's simply my preferred interpretation for explaining how God relates to time. In the video's attempt to marginalize these theories, Kevin, what tends to get overlooked, I think, is the fact that they are scientifically unimpeachable.
And back to Vilenkin.
If something could come from nothing, then why doesn't this happen all the time? Why don't tigers just appear in our living room?
In quantum mechanics, many things are possible that are not possible in classical physics. And indeed, you can have, in principle, you can have very strange things happening, like objects coming out of thin air. A lump of matter, in principle, it can turn into a tiger. And quantum mechanics will not tell you that this is absolutely impossible, but if you try to calculate the probability of this happening, it will be pretty low. If you think of the quantum creation of the universe, it is a tiny microscopic universe, right, that has to pop out of nothing. If you calculate the probability of this happening, I should say that conceptually this probability, interpreting this probability is a little difficult, but still, if you do the calculation, you find that it is far more probable than having a tiger materialize in front of you.
The low probability of such remarkable quantum physical transitions has nothing to do with the possibility of something's coming into being uncaused out of nothing. Something's popping into existence from nothing is not governed by physical probability. The idea of a probability of something's coming into being from nothing is meaningless, since there is no physics of non-being.
Next is another clip from Arif Ahmed.
The argument that something can't come from nothing, or perhaps it'd be better to say something won't ever come into existence following nothing, isn't really confirmed by our everyday experience, because in our everyday experience we don't ever experience a nothing and check it to see whether something can or can't come from it. So there's no argument at all, I think, on the basis of what we've observed in everyday life at all, to think that something can't come from nothing.
Such a reply is badly misconceived. The inductive evidence in support of the causal principle appeals to our observation of things that begin to exist and noting that there are causes for them. The Copenhagen interpretation of quantum mechanics claims to provide evidence for some exception to this inductive evidence, but as I say, that interpretation is highly disputable, and so it is not a proven counterexample to the inductive evidence.
In this next clip, they bring back Alastair Williams.
It isn't just quantum mechanics that divides thinkers about the nature of causality. Philosophers are equally unsure of its merits.
So causation is a classic philosophical topic in the sense that there's no agreement about it at all, and there hasn't been ever.
What he means is that there is no consensus concerning a philosophical analysis of causation, either that an analysis can be successfully given or should be given. The metaphysical principle that out of nothing, nothing comes has been nearly unanimous in Western philosophy ever since Parmenides.
Here's the next clip.
If the universe had a beginning, it's hard to see how it could have a cause. After all, we tend to think of causes happening before their effects. But if time began with the universe, then there was no before. So how could God have caused it?
LOL. I thought that we were just told that there is no agreement on the nature of causation and that common sense cannot be trusted.
And this next clip is an excerpt from you, Bill.
And I frankly just don't understand why people think that causality is a temporal relationship. For example, philosophers talk all the time about cases of simultaneous causation, where the cause and effect occur at the same moment of time. Immanuel Kant gave the example of a heavy ball resting on a pillow, causing a depression in the pillow. Now, the ball and the pillow could have existed from eternity past.
This seems like the admission of something that's existed for a past eternity. So it may be that Craig, by using this example, is allowing, and he may not consistently be able to allow, that something's existed for a past eternity.
Kant's example is intended to be an illustration of simultaneous causation. Neither I nor many other philosophers see any reason to think that a cause has to be temporally prior to its effect. In fact, it's very difficult to see how it could be prior to, but not simultaneous with, its effect. If simultaneous causation is possible, then God's causing the universe to come into being is simultaneous with the universe's coming into being. What could be more obvious?
Here's more on that in this next clip.
In physics literature, there is no such thing as simultaneous causation. So the notion of causality in physics always has a chronological nature, that basically the cause should precede the effect. And in this particular example of the ball and the pillow, if you just look at things as they are at one instant, then you cannot really make any statement about causality. But if you look at the history of what preceded what, basically you put a ball somewhere, and then its effect propagates with the speed of sound through the medium, and the pillow basically accordingly reacts to that.
Obviously, physical influences are propagated by finite velocity signals, but the effect will not come into being until the signal actually contacts the patient entity. That is, say, the recipient receives the signal. At any instant prior to that point, the signal could be intercepted and the effect would not be produced. In any case, divine causation is not mediated by the transition of physical signals.
And this clip from Alastair Wilson.
Some concepts only make sense when applied within the universe or within some part of the universe. I mean, if you ask how much something costs, some table or some chair, then that makes perfect sense and there's a good answer. If you ask how much the universe costs, that doesn't really make sense because you can't step outside the universe to buy it. It could be very similar with cause and effect. Cause and effect is something that operates inside the universe. So it just doesn't make sense to step outside the universe and ask what causes it. Cause and effect is something that happens within the universe, not to it.
I find this claim utterly implausible. The causal principle is a metaphysical principle which applies to reality as such. Namely, being does not arise from non-being. It is not a natural law like the laws of thermodynamics or the law of gravity, which apply only within the universe. I think that what we're seeing here is a subtle scientism that reduces everything to what science tells us and rejects any metaphysics that is not simply an extension of science. And do I need to say that such scientism is scientifically unprovable and nothing more than a philosophical prejudice?
The narrator brings up bouncing cosmology in this next clip.
We've seen that many cosmologists favor a bouncing cosmology, which may be eternal into the past. Others favor a universe that had a beginning from a spontaneous fluctuation. Another class of models suggests that solutions to Einstein's equations that allow time travel into the past, known as closed time-like curves, could enable the universe to create itself.
Our narrator has never met a cosmological model that she doesn't like, unless it involves a beginning. The question is not the existence of theoretical models. The question is their mathematical consistency and their empirical adequacy. There is no model that meets those conditions and is past eternal.
And they feature a clip from you in this next clip.
This is clearly impossible, for in order to create itself, the universe would have to already exist. It would have to exist before it existed, which is a self-contradiction.
It may be inconsistent for Craig to say that, on the one hand, causes do not have to precede their effects in time, but then on the other hand, dismissing the idea of a self-created universe on the basis that a self-created universe would have to precede itself in time.
Fair enough, but the point is that in order to bring itself into existence at t equals 0, the universe would have to already exist at t equals 0, if not before. I mean, seriously, is this now the alternative to theism?
More on a self-creating universe in this clip.
So a self-creating universe may appear to be a contradiction if you imagine a linear direction of time, because if you have some cause that leads to our universe, then that cause should precede the effect. But if you have a circular time, then there is really no notion of cause and effect, and because of that, there is no contradiction, because basically all you have is a consistency condition between what happens at one era and what happens at a prior era or future era, because they all just lead to each other. And as long as those consistencies hold, there is no contradiction.
Whoa, I thought that my espousal of Bohmian quantum mechanics and neo-Lorentzian relativity was untenable because such theories were fringe and disreputable. But this, C. Jim Sinclair's discussion of the Lee-Gott model featuring closed time-like loops in the Blackwell Companion to Natural Theology. For my part, I reject such models as metaphysically impossible because on a tensed theory of time, according to which temporal becoming is real, the universe would have to come into existence from nothing, since at the time of its origin, its future states in no sense exist.
Here's what the narrator says in this next clip.
In order to assert the universe must have been created by an agent with free will, Craig uses an argument from the medieval philosopher Al-Ghazali, which asserts the universe must have arisen spontaneously, and the only example of spontaneous action is that of a free agent, something we supposedly know from our everyday experience of the world.
Well, not exactly. The point, rather, is that the only way to get a temporal effect with a beginning from a permanent, changeless cause is if that cause is a personal agent endowed with freedom of the will and so able to produce an effect without any antecedent determining conditions.
Here's more from Alastair Wilson.
I mean, I think it's a pretty good argument. It's just that the premises we no longer tend to accept. The kind of modern conception of the world, the standard view of quantum physics is that it's not deterministic after all, that most interpretations of quantum mechanics have some indeterminism in them. And the most popular approach to understanding free action tends to be compatibilist. It sees free action as compatible with the laws of physics, indeed enabled by the action of the laws of physics. So Al-Ghazali's argument was pretty good, given the assumptions he was making. It's just that I don't think we now have any reason to accept those assumptions.
Here we come back to the point quoted earlier from Aguirre and Casillas that a quantum state can't endure changelessly from eternity and then suddenly produce a new effect a finite time ago. So quantum indeterminacy won't do the trick here. Notice too that Wilson's understanding of compatibilism is mistaken or idiosyncratic. Compatibilism is the view that freedom is compatible with your being completely determined in everything that you do.
Here's Arif Ahmed in the next clip.
If you're in the game of appealing to everyday observations, then there's all kinds of things you can say that would be unhelpful to the Kalam argument. For instance, we observe that every event has been preceded by another event, but clearly the Kalam argument can't allow for that. We observe that everything that comes into existence has a material cause, if it has a cause at all, but again, the Kalam argument can't allow for that. We observe that all agency, for instance, all intelligent agency, is material. But again, the Kalam argument can't allow for such things. So everyday experience furnishes all kinds of generalizations that are inconsistent with the conclusion of the Kalam argument. And it's just arbitrary to choose the generalizations that you like from everyday experience and ignore the ones that don't fit with your conclusion.
I deny that we observe that every event is preceded by another event, or that every intelligent cause is material. The principle that everything that comes into existence has a material cause, if it has a cause at all, is indeed powerfully supported by inductive evidence. But it gets defeated by the evidence for the beginning of the universe, which cannot have a material cause.
Bill, we have come to the last clip, and this is how the narrator summarizes everything.
To summarize, the Kalam Cosmological Argument is based on an outdated view of mathematics and an outdated view of physics. Mathematicians don't deny infinity, and physicists no longer believe the Big Bang is the beginning. The argument assumes our everyday experience of causality must hold true, even when there is no space or time, but then claims an immaterial mind made the universe from nothing, which is completely contrary to our everyday experience. In short, the Kalam Cosmological Argument is unsound.
Oh, please. The first philosophical argument for the beginning of the universe is based on modern Cantorian set theory. It argues that if there were an actually infinite number of things, then various metaphysical absurdities would ensue. In contrast to intuitionistic mathematics, the argument does not deny the mathematical legitimacy of the concept of the actual infinite, but rather employs it. The second philosophical argument is rooted in a tensed theory of time, which I have defended at length in my published work. As for the two scientific confirmations of the beginning of the universe, from the expansion of the universe and from the thermodynamic properties of the universe, it's just laughable to think that an argument appealing to cutting-edge work in astrophysical cosmology and constantly updated in light of it is based upon outdated physics. Many contemporary scientists do believe in the beginning of the universe, even as they explore models aimed at falsifying that prediction. The video's producer doesn't seem to understand that the universe is having a beginning doesn't imply that it begins to exist at a singularity as it does in the standard model. Finally, the causal premise of the argument is based on both metaphysical arguments and inductive evidence. It is in accord with, but it is not simply based on common sense. And so I think the video's conclusion is vastly overdrawn. To sum up, Kevin, I want to say I'm genuinely grateful to the many scientists and philosophers who took the time to be interviewed for this video. This sort of vigorous debate can only raise the visibility and the influence of the Kalam Cosmological Argument. Unfortunately, it's very clear that the script was determined by the producers in advance. What we observe in this video is not an objective piece of investigative journalism, but rather a polemical piece consisting of mutually inconsistent, often irrelevant, and increasingly desperate objections aimed at undercutting the Kalam Cosmological Argument. There's no genuine interest here displayed at all in learning whether and or how the universe began to exist. All that matters is perceiving loopholes. And as the video proceeds, increasingly bizarre and implausible scenarios are suggested for avoiding the beginning of the universe without any attempt at all at their evaluation. When we finally get to the point that in order to avoid the argument's conclusion, we're advised to believe instead in circular causation or spontaneous generation ex nihilo, then I think we know what the desperation is really all about, namely avoiding theism at all costs.
Well, you did it, Bill. 4-part series on this rather extensive video. I want to remind everyone that they can get more when they go to reasonablefaith.org. Go to the Question of the Week series where you address more on this. We'll see you on the next podcast. Reasonable Faith with Dr. William Lane Craig.